Hi everyone. In this video, I'm going to continue going over the questions from the 2010 PAT. All right, if you have made it this far, I am so proud of you. I've been filming this all day, so I am tired just like you, probably not as tired as you are. So with that being said, let's get started with number 32. Okay, so we have question number 30 here. In a survey, 500 people were asked to name their favorite sport. The results of this survey are shown below. So we've got a few different options going on there. If the results were displayed on a circle graph, then the measure of the angle that would represent how many people selected football would be approximately blank. Now, this is a good question. It kind of takes you back to we're representing information using a graph. This is specific to the grade 8 curriculum. So I've left a little formula here that says the angle is equal to the number of choices. So in this case, football over the total number of people. Then what we'll do is once we get that fraction, we're going to times it by 360. So in this case, we have 122 people over the 500. And then we're going to times that by 360. So remember to do this portion first and then times it by 360. Once we do that, we're going to get 87.840. That's going to round up to 88 degrees. All right, number 31. Ben was earning a monthly salary of $5,000 before he changed jobs. At his new job, he earns 10% less than he did at his old job. After 1 year of being at his new job, Ben receives a pay increase of 15%. How much will he then be earning per month? So again, a great one taking us back to percentages. So we have to do a few different things here. The first thing we need to figure out is how much is he getting paid at his new job. So we're going to do this by taking his original salary of $5,000, and we're going to times that by 10%. Now remember, with the percents, 10% is going to be like 10 divided by 100. That's going to be 0.10. And same thing with this 15%, it's going to be 0.15. So I'm going to take that and times that by 0.10. That's going to give me 500. We're really just moving the decimal over. And now we're going to subtract that because the old job, he was earning this much money, but now he's earning 10% less. So that means at the new job, he's earning this. Now what we want to do is we know that he got an increase of 15%. So we're going to take the money that he's getting at the new job, so the 4,500, and we're going to multiply that by the 15%. So the reason we're doing that, I forgot to mention, is when we see like a percent and it says of something, we can consider that as multiplying. So, sorry, I'm going to change that 15% to 0.15. That's going to end up being $600.75. So this is his actual increase, right? Because it says he got an increase of 15%. So now we're going to put these amounts together to get his total. So when I add those up, I'm going to get 5,175, which is C. All right, so I do love this question. It's got my name in it, so, even better. I'm also realizing how dated the question is because it is talking about CDs. So Jenny notices that a music store is having a no GST and 40% off the regular price. If the regular price of a CD is $15.99, then what is the maximum number of sailed CDs that Jenny can buy with her $80 gift card? So there's a few ways to do this. I'm actually going to show you another method for when it comes to percentages. So the first thing we can do is we can convert our 40% to a decimal. So I'm going to do that by going 0.40. all I'm doing with that is just dividing the 40% by 100, moving that decimal value 2 spots over. Then we can times that by 1599. What that is asking, by doing that, what we're doing is we're figuring out what is 40% of 1599. So that's going to give me $6.39. Really, I'm going to actually probably round. I'll keep the decimals. I will round at the very end. So 40% of this is this much. Now that's not actually how much she's paying. That's how much her discount is going to be. So now we have to take the original price of the CD and subtract it from the value that we just got. So when I do that, that's going to tell me that she's paying $9.59 per CD, right? I didn't round anything. So that means one CD at the sale price costs that much. So we want to know, okay, how much can she buy with her $80 gift card? We're going to take our $80 gift card and divide it by the one CD that she can get, or the cost of one CD that she can buy at the sale price, and figure out what that equals. Once I go 80 divide by that, I actually get a weird number of 8.33. Now, there's a good chance you're going to get a question like this where you're going to need to think about how you want to round. In this case, it's pretty good. So 8.3, you can't really round up. That means our total is going to be 8. She can get 8 CDs with this gift card and the sale price. Sometimes you might see something. Let's pretend the answer was 8.6. Okay? It might be tempting to round up, but we have to look at the scenario of the question. The question asks how many CDs she can get. If the answer was 8.6, and it's not, I want to be clear, but if it was 8.6, you can't buy 9 CDs because the gift card only allows for 8 whole CDs and 0.6 of a CD. Since they don't sell items like CDs and other items at a 0.6 of it, or whatever the fraction is, we're still going to have to round down. So my point in that is be really careful with what the question says when you all are taking your exam. Sometimes you're going to get a weird decimal and you have to read the question, read the context of the question to decide if you're going to round up or round down. In this case, either way, the amount of CDs she can get is 8 and that was our answer. Okay, number 8 here. At a picnic for 49 people, 4 families each brought an equal number of lawn chairs. 5 more lawn chairs were still needed. How many lawn chairs did each family bring? Okay, so an interesting question here. What we're trying to say is we know we have our total of 49 people, and we know they each brought an equal amount of chairs. We know that each family brought an equal amount of chairs. So what I'm going to want to do is set this up with my total. So 49 is equal to 4 families bringing an equal amount. So normally when we say each or per, we want to think of multiplying. So what I'm going to do here is I'm going to go 4 times X plus the fact that they still needed 4 lawn chairs. 5. And so X is equal to the number of lawn chairs. So now what I want to do is if they want to know how many chairs did each family bring, I'm just going to solve for X here. So I'm setting up a 2-step equation here. So I'm going to minus 5 from both sides. That's going to get me to 44 is equal to 4X. Divide both sides by 4 because we want to get X alone. So X is equal to 11. So each family brought 11 chairs. Okay, so we want to know what is the scale factor of this enlargement. So they gave us an image. They said, here's the original and here's the enlargement. So we know no matter what, based on the word enlargement, we are going from the smaller image and we're blowing it up. So essentially, and I can do it here, it works really well. Essentially, we're starting off with like this tiny image here and we're blowing it up. So whenever we're blowing up an image, what we're saying is the proportions are going to stay the same. And my analogy for this is if you think of like looking at a photo on Instagram, when you like zoom in on it to see, it's going to look, it should have the same proportions. If it doesn't, someone's going to look distorted and that's going to look a little odd. So what we want to do here is we want to take the image that's been enlarged. We want to count all of those and divide it by the original. Now, if you forget this on the test, really just think about which way you're going. If you are making a shape bigger, right? Like obviously this is my small shape and this is my bigger shape. You know you're probably multiplying by a whole number. If we were going the other way, we were taking a big shape and making it smaller, then you know you're multiplying by a decimal or you're dividing, okay? So keep that in mind. That number sense can really help to solve something like this. So for this question though, when I count it out, I am gonna go through each part of the new image. So that's gonna give me 12. And then the original was 1, 2, 3, 4. Notice how I am using corresponding sides, right? I cannot, count the length on this side and then count the one on this side for the other triangle. It has to be the same sides. So 12 divided by 4 gets me to 3. So the scale factor for this is 3. If you were also unsure, one thing I'll add is you could, doesn't really work well for this shape because it's diagonal, but let's say it's a rectangle. We know that this is 3 down. So if I'm making it bigger and then I counted this side, this would also be 3 times bigger than the original. So if this is 3, then 3 times original would mean this side is 9, and they would be proportional to each other. So the answer for this one is 3. All right, number 33. Various points have been plotted on the graph below. The title of the graph and the labels of the axes have been omitted. So basically, we don't really know what this graph is talking about. We want to know which of the following statements is a possible interpretation of the graph above. So here's what I do know. I know my y-axis stands nice and tall. So this is my y-axis and this is my x-axis. Normally the y-axis is what we are measuring and the x-axis is kind of like what is going into the system. In elementary, we almost always called it input and output. Perfect. So that takes care of that. What we want to do is figure out, again, a possible interpretation. So Nicole earns $20 for each hour she works. Okay, so what we're saying then is if she worked 1 hour, she would have $20. That doesn't work because that's not going to correspond. And normally if you're measuring something, it's going to be on the y-axis. So that one's probably not going to work. For every 10 swimmers, 2 lifeguards are needed. Okay, well again, 10 swimmers, we have 1 lifeguard. Not gonna work. For C, it says for every 10 pieces of candy Simone buys, she pays $1. Okay, 10 pieces of candy, she pays $1. And that would make sense because we said money often goes on this side or what we're measuring. If I were to go with that scenario, I could double it. Well, if she bought 20 pieces of candy, then she would pay $2. Okay, I'm liking that. It looks like a good linear expression. D, we always have to check the last one. A runner runs at a constant speed of 2 kilometers every 30 minutes. Well, here's my 30 minutes. That would be 3 kilometers. That's not going to work. So, oops. So for this, our answer is going to be C. Okay, number 35, we're getting so close to the end. In a science experiment, a solution has an initial temperature of 20 degrees Celsius as shown below. If the temperature T of the solution drops 2.8 Celsius, so 2.8 degrees per hour, then which of the following equations can be used to calculate the temperature of the solution after 4 hours? Now, this is one of those great questions where math and science like to come together, and you're going to have a lot of that in high school. I want to say I'm sorry, but I'm not. It's what it is. Okay, so first thing I know is we have this as your initial temperature. That means when we're trying to find the temperature, like the overall temperature, we are going to have to start with 20 degrees, and from there we're going to take away something. So that already allows me to eliminate this and this, because this is adding something. The reason I'm going to take it away is because that's my initial temperature and you want to remove everything. The other reason is this also drops. Okay, now from there, we know it's dropping at a rate of 2.8 for every 4 hours. So 1 hour, it's going to be 2.8 less. Then the second hour, it's going to be 2.8 less. And you get the idea. It's going to continue. So with that, we know we're going to obviously be multiplying it by 4. But these two ideas, the per rate per 4 hours, that's a rate. That's going to be put together in brackets because, of course, it's dependent on how far it falls within those 4 hours. So that means when I'm looking at these two, I have brackets here and brackets here. Because this one says 20, take away this, but we're going to times it by 4 hours, that wouldn't account for the fact that the system was already 20 degrees to start with. That would actually like quadruple our initial temperature, which we wouldn't want. We're starting off with 20, and then over time, the temperature goes down. So the only option that's going to work for this one is going to be A. Okay, numerical response number 10. So a person who is 200 centimeters tall casts a shadow that is 40 centimeters long. So that's the first sort of idea. The second one says at the same time, a nearby post casts a shadow that is 16 centimeters long. We got to determine the height of the post. So what I'm going to want to do with this is I'm going to just draw this. Here's my person that's 200 meters tall. And then here's their shadow at 40 centimeters. Now the same thing, because the sun is in the same place, is happening. And we just know that this shadow is 16 centimeters long. Notice how I'm keeping my shadows obviously on the ground, and the stuff that are standing at the top are just standing there, right? There's nothing I'm doing with that. So from there, this is really just going to require me to use some scale factors to figure out what is the connection between this, and then use that same connection to figure out how tall the post is. So I am going from big to small. I'm probably looking for a decimal here. So I'm going to go 40 centimeters divide by 16. Again, that is my corresponding side. So that's going to give me 0.4. And then what I can do is I can go, if this is my scale factor, I can take my original 200, multiply that by 0.4, and that's going to get me 80. So the post is 80 centimeters tall, and that's my answer. Number 36 here. So basically they gave us a graph, and what we want to do is figure out the equation that represents the graph above. So the first thing we should do is come up with a table, like our input-output table. So that's going to look something like this, right? So there's my X on the bottom, my Y's, and what we know is that the Y is decreasing by 2 each time. We are minusing 2 each time. So what that tells me is in my equation, my X will become 2X. We're going down by 2 each time, so it's going to be negative. Now the other part is the number that I need kind of like next to that X is the number of Y when X is 0. So that number is 5, positive 5. So that should be my equation. Now, if I was unsure, I can go ahead and check it. I can say negative 2 times 1 plus 5. Well, negative 2 times 1 is going to be obviously negative 2, plus 5 would equal 3. That completely corresponds with the graph there. So that means I know my equation is going to be this right here. All right, number 37. So a school principal asks every student and staff member in the school if they like the idea of school uniforms. The school has 450 students and 30 staff members. So for this one, the survey uses blank, and blank would have the most influence. Well, I already know right away, based on the numbers, there are more students than staff, so students would have the higher influence. So I can cross off this and cross off this. Now I have to ask myself, am I just asking some students, which would be a sample, or am I asking all the students, which would be a population? Well, it says here I asked every student, so that means my answer is going to be C. All right, just as last time, I'm going to share a clip from my YouTube video that goes over the next question.
Okay, let's start off with this question here, number 38 from this PAT here. So a couple of things to notice here. The first thing is they gave us a tangent. Now remember, a tangent is a straight line, and because it's a straight line, it is actually going to have an angle of 180. So that means we can use that to figure out the angles of everything else. So if this whole portion is 180, meaning from here to here is 180, well, we can subtract our unknown angles to figure out the missing angle here. And oh, I'm so sorry, I'm jumping ahead. Let me read the question. So the question wants us to figure out the measure of this angle here, so that angle X. So we're gonna use that tangent along with our properties of triangles to figure out that unknown side. Sorry about that. So once I look at my 180, I can actually remove the 70 degrees that they gave us along with our 60 degrees that they gave us. Altogether, that's going to give me 50. So if that's 50, what that means is this angle inside here is going to be 50. Now we got to think back to our elementary math. So one of the things that we know is all triangles have angles that add up to 180. So if that's the case, we're then going to need to take up all our angles here of 180 and remove our known parts to figure out the value of X. So we're going to have to go 180, take away the 60 that they gave us and the 50 that we just found out. So that's going to leave us with angle X is going to equal 70. So therefore, our answer is going to be D.
All right, my name's in here again, which is now kind of telling me that my name is dated because this is an older test. So I'm gonna ponder that when I'm done filming. Okay, so Jennifer wants to buy a computer that costs $2,000, including all taxes. She will make a down payment of $500 and arrange to make 5 equal payments for the balance owing. Which of the following expressions can Jennifer use to determine the amount of each of the 5 equal payments? Okay, so this one isn't too bad. The way I'm gonna write it is as if I didn't have the equations on the side there, I guess at the top there. So 2,000 is equal to $500 down plus the 5 payments she has to make of an unknown amount. Okay, so now we can kind of do this in reverse and figure out which one is going to be the equation. So if my goal is to get X alone, I'm going to want to minus 500 from both sides. And I'm going to rewrite that. And then now we're saying X is being multiplied by 5. So to get that alone, I'm going to divide both sides by 5. That's going to cross off my X, leaving me with something that looks like this. So I'm looking for these two numbers subtracted, divide by 5. Well, the only one that's really fitting that is option A. All right, everyone, you did it. We are at our last question. I'm super stoked because I've been filming all day. Normally when I do these, I break it up over a few days. And I can only imagine how stoked you are. Or not stoked because you don't want to take the PAT. But regardless, we're almost done. Let's head over into that last question. All right, the following list shows Ricky's early vehicle expenses. And yeah, owning a vehicle is expensive for those of you that are thinking about it. So what we know is the total of his expenses is this much here. And, oh, it's Rick's. I read that wrong. And Rick works 8 hours a day at 5 days a week and takes home $10 an hour. So that means in one day, he's getting $80, not including taxes, of course. Times that by 5 will get me to $400 a week. Now we want to know how many weeks it's going to take for him to pay this. So what we're going to do is take our total amount and we're going to divide it by the 400. And that's going to get me to 8.37. Now, this is one of those ones that I was talking about earlier. We get a decimal and it's tempting to say it's going to just take 8 weeks. However, it wants to know the total unit in weeks. We can't say it's 8 weeks because that would mean Rick still has a few days of extra work. So instead, we want to know the least amount of weeks. We're going to have to round up, meaning the answer for this isn't C, but rather D. We're going to round that up to 9. All right, everyone, congratulations. You made it through this math PAT. I know it was a long one. Hopefully everything made sense, and I really hope this was able to help you with the upcoming math PATs. I do have videos to science PATs in case you are looking to help, in case you're looking for something to help you study for that. Until then, everybody, I will see you all in the next one. Bye.